In this video, we're going to cover section 2.1, which is testing for validity using truth tables. So we're going to begin chapter 2, which is all about arguments. An argument is a collection of true-false statements called premises, which are always assumed to be true, followed by a final statement called the conclusion of the argument. The conclusion is often preceded by the word therefore. So in order to show that an argument is valid, we must prove that, but based on the truth of its premises, then the conclusion must be true. So in order for an argument to be valid, the conclusions must always be true if the premises are true. If true premises lead to a conclusion that's false, even just one time, then the argument is said to be invalid. So one way that we can determine if an argument is valid or invalid is to construct a truth table. So there's going to be a couple of different ways that we could prove the validity of an argument. In this section, we're going to start by using truth tables. So let's look at an example. The first example says determine whether the argument below is valid or invalid. We will go to the game or study. We will not study. Therefore, we will go to the game. So that's how I could tell that this is an argument, because we have two premises. The first one is we will go to the game or study. The second one is we will not study. And the conclusion, because it's preceded by the word therefore, we will go to the game. So in this section, like I said, we're going to use truth tables to determine if an argument is valid or invalid. So let's use G for we will go to the game. We'll use S for we will study. So we have two variables in this case, G and S. So let's model the first statement. We will go to the game or study. So that's going to be G or S. We will not study is going to be not S. And then the conclusion, we will go to the game. So we will go to the game is going to be J. So let's make a truth table that includes these premises and then the conclusion. So first we start with listing the possible truth values for the variables involved, right? Which are just G and S. So we start with G and S, a column for both. And now let's list the premises. So we have G or S. My second premise is not S. And then we have the conclusion, which is G. So let's construct a truth table. So since I have two variables, either we have true, true, false, false, or true, false, true, false, right? That makes up my four different true, false combinations. Now let's set the truth column for G or S. So the only way an or statement is false is if both statements are false. So true or true is true, true or false is true, false or true is true. So if you have at least one true, remember, then the statement's true. False or false is going to be false. Now, not S, we're going to negate the second column, right? So we're going to have false, true, false, true. And then the conclusion is just G, and we already have that at the beginning, so we could recopy that. So let's go back up here and just remind ourselves that in order for an argument to be valid, we must prove that based on the truth of the premises, its conclusion must be true. So in other words, for an argument to be valid, the conclusions must always be true if the premises are true. So let's go down to our table, and I'll use a different color so it'll stand out. Go to the premises, right? So here's a premise and here's a premise. Where are both premises true? Here, right? We have a true and a true premise. So in order for this argument to be valid, the conclusion must also be valid. So if we look over to the conclusion, which is G, I see that it's also true. Therefore, this argument is valid. since whenever we have premises that are true, it always leads to a true conclusion. Let's look at the next example. Determine whether the following argument is valid or invalid. So very similar to what we did before. So if I lift weights, I'll become stronger. I became stronger, therefore I lifted weights. So we have two premises again and a conclusion. Let's use W for I lift weights, S for I become stronger. Now let's model the premises, right? So if I lift weights, then I will become stronger. So W implies S, right? We have a conditional statement. I became stronger. So that's going to be S. Therefore, I lifted weights. And that's W. So let's make a truth table. So the only two variables we have are W and S. Now let's list the premises, right? So we have the conditional statement, W implies S. And honestly, you don't have to write S again and W because S happens to be the second premise and W happens to be the conclusion, which we're already going to list right here. But if it makes it easier for you to look at it, from left to right, you can include them again. So it's a little repetitive, but I'm just going to include it again. So look, this is my second premise, and then here's my conclusion. So we have premise 1, premise 2, conclusion. So let's list our true false possibilities for W and S. So we have true, true, false, false, true, false, true, false. Now with the conditional statement, the only way we're going to have a false conditional statement is if the left-hand side is true, the right-hand side is false. Otherwise, the statement's true. So true implies true is true. We just said true implies false is false. False implies true is true, and false implies false is true. Now, like I said, we didn't have to continue the table here because we already have S listed and we already have W, and we could have just looked from right to left. We could have just looked backwards. But if it's easier, like I said, to look at it from this perspective, just list these again. So look, we have S is true, false, true, false. So I just rewrote this column right here. And then W is true, true, false, false. So what we want to do is look at when the premises are true, when they're both true, right? So here I have both premises are true, and here's another way that both premises could be true. But now we have to look at the conclusion. If the conclusion is true in all instances, the argument's valid. So look, we have a true conclusion. So far, so good. But now when I look at the other possibility where both premises are true, look, my conclusion's false. So since it's not true for all, right, possibilities when both premises are true, it's invalid. Okay, so it's invalid because of that scenario. Whoops. So let's continue on. So we'll do 3 more examples, and then we'll talk about using a counterexample. So a counterexample is when we determine that an argument is invalid, we could write down the case or cases where the conclusion is false, even though the premises are true. But we'll do that in a little bit. So first, let's just use a truth table to determine if the following arguments are valid or invalid. So let's start with the first one on the left. So let me also talk about before we do this, the ones that I did up here were in words. So it just looked like a paragraph, right? When we're given an argument in symbols, this is typically the way we write it. The premises are listed first, and then a line is drawn, and then we have the conclusion. So another way to kind of look at the first one is we have if C, then D. If E, then D. Those are the premises. Therefore, C implies E. So that's my argument. So this is what it would look like already written up in symbols. So the conclusion comes after the premises always when we write it. So in this case, we have two premises and a conclusion. And we have three variables, C, D, and E. So let's start with C, D, and E. Now list your premises. So the next one is C implies D. Then my next premise is E implies D. So this is for this one. And then my conclusion is C implies E. So let's see what happens when we construct this truth table, if we end up with an argument that's valid or invalid. So now that we have three variables, right, I'm going to have 8 different true-false combinations. So the way we start is true, 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 false, 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 false. And then we have true, true, false, false, true, true, false, false. And then true, false, true, false, true, false, true, false. Now let's list the truth values for C implies D. So we're just looking at the first 2 columns for C and D. So first we have true implies true, which is true. And then we have that again, that's true. Then we have true implies false. Remember, that's the only instance where a conditional is false. Then we have false implies true, which is true. And then we have false implies false, which is also true. So now we have E implies D. So we're looking at E and D. And E comes first. So we're looking from, like in the first one, E implies D, we would have true implies true, right? So we're looking that way. So that's going to be true. Then we have false implies true, which is true. Then we have true implies false, which is the false case, right? False implies false, which is true. True implies true, which is true. False implies true, which is true. True implies false, which is false. And then false implies false, which is true. So now let's look at the instances for the conclusion, which is C implies E. So now we're looking at the first and the third column, and we're using the conditional statement, right? So true to true is true. True to false is false. True to true is true. True to false is false. False to true is true. False to false is true. We said false to true is true. And then false to false is true. So we've completed the truth table. And now we want to check to see, okay, when are my instances that all my premises are true, right? And we have the 2 premises, C implies D, E implies D. So here they're both true, right? Here they're both true. Here they're both true, and here they're both true. So now in order for this argument to be valid, all of the associated conclusions must also be true. So the first one is true. So far, so good. Now we have this instance, though, where look, the conclusion's false. These 2 here are both true. This one's true. So this is the example here that makes this argument invalid, because I have these premises that are true, but it's leading to an argument that's false. So this is an invalid argument because of that case. So let's look at the next one. We'll do the next one over here. So we have not R and S. S, so those are my two premises, and therefore that leads to the conclusion, not R. So let's check and see if this argument is valid or invalid. So let's set up our truth table. So we have, just make this a bit shorter. So we have R, S. Those are my two letters, right? My two variables, or my simple statements. And then we have R and S. And then we have not R and S. And then the other premise is S, which I'm not going to list. We did it in the previous one when we were first kind of getting familiar with this, but I'm not going to repeat S again. Let's just look backwards when we have to, and then we'll make a column for the conclusion, not R. So we're going to have true, true, false, false, true, false, true, false. So we have a conjunction, R and S. The only way this end statement's going to be true is if both are true, right? If there's at least one false, the conjunction is false. So we have true and true, which is true, but then all the other ones are going to be false because there's at least one false. Now let's look at not R and S. So we're just going to negate the column that we just did, right? So we're going to get false, true, true, true. And now we have not R. So let's negate the R column, right? So we're going to have false, false, true, true. So let's look at our two premises, right? So my two premises are not R and S and S. So let's look and see when they're both true. So that's going to be here and here, right? When both S and not R and S, my two premises, are true. And now, so there's no other instance where both premises are true. So now, in order for this argument to be valid, then the conclusion would have to be true. And the conclusion is not R. So if we look at not R, we get true. Therefore, this argument is valid. So this argument's valid. So let's do one more. Let's look at this third example. We have three premises this time, not S, S or Q, and P if and only if Q. And then my conclusion is not P. So I'm going to set up my truth table right here in this little right-hand corner. So let's list our simple statements, right? The variables. So we have P, Q, and S. So my first premise is not S. My second premise is S or Q. My third is P biconditional Q. And then my conclusion is not P. All right, so let's set up our table. So let's list the 8 possible truth value combinations for P, Q, and S. So now let's go to our first premise, not S. So let's just negate the S column, right? So we're going to have false, true, and so on and so forth. Now my second premise is S or Q. So we're looking at the second and the third column, right? S or Q. So we're going to use the values for Q and S. With the or statement, remember, as long as there's one true in there, the statement's going to be true. The only time an or statement or the disjunction is going to be false is if it's a false or a false. So the first one for S or Q is going to be true or true, which is true. Then we have false or true, which is true. False or true, which is true. And then here's the case of false or false. So that's going to be false. Then we have true, true, true. And then another case where it's going to be false. So now the third premise, P if and only if Q, the only way the biconditional is true is if both the left-hand side and the right-hand side are the same. So either true if and only if true, or false if and only if false. And we're looking at the first two columns, right? Because it's P biconditional statement Q, right? So we have true and true, which is going to be true. Then we have true, true, which is true. Then we have true if and only if false. So that's going to be false. Again, true if and only if false. So that's false. False if and only if true. So that's false. Then again, that's false. Then we have F if and only if false, so that's true. And then F if and only if F, which is also going to be true. So on the left and the right-hand side are the same with the biconditional. We have a true statement. So now let's look at the conclusion. The conclusion is not P, so I'm just going to negate the first column, right? Because P is the first column. So we're going to, all the trues become false, all the false statements become true. So we've completed our truth table. And now we're ready to look at where are the instances that my three premises are all true. So we have this, they're all true. And that's it, right? So the only time all those premises are true is that case right there that I just circled in red. I'm just browsing again one more time just to make sure I didn't miss anything. So now let's look at the conclusion for when all this instance where my three premises are true, the conclusion is false. Therefore, the argument is invalid. So this third argument is invalid. So we're going to look at a couple of more examples, but now what we're going to do in addition to testing to see if an argument is valid or invalid, if it's invalid, we're going to produce a counterexample chart. So like I said earlier, it's just an example that shows the argument is not valid. So once we do these examples, I'll highlight how to come up with the counterexample chart. So let's just do what we were doing earlier, and let's make a truth table to see if the argument is valid or invalid. But if it's invalid, now we're going to produce a counterexample for each. So let's look at the first one. So we have two premises, W implies S, and then S, and then my conclusion is W. So we're going to have S and W. And then my first premise is W implies S. Then we have S for the second premise, and then W is the conclusion. And we already have S and W, so I'm not going to do any more work than I have to. We'll just look backwards in the table when it's necessary. So we're going to have true, true, false, false, true, false, true, false. Now let's look at the truth values for W implies S. And make sure you're going the proper way, right? W is on the left-hand side, S is on the right-hand side. So we're looking from W to S. So the first one's true to true, which is true. The second one is false to true, which is true. Then we have true false, which is false, and then false to false, which is true. So let me just get rid of these arrows. Okay. So now let's look at the conclusion when the premises are true, right? Because I already have S, my other premises right here, and then W, my conclusion is right here. So let's circle the instances when both premises are true, when S is true and W implies S is true. So we have here, right? And then here, S is also true and W implies S is true. So those are the two instances when the premises are true. Now let's look at the conclusion, which is W. So W is true here. So far it looks valid, but then now when we go to the other case where both premises are true, the conclusion is false. Therefore, this argument is invalid. And the counterexample would just be this. So what we do for the counterexample is we just list, so for example, we only have S and W, right? So what would the values of S and W have to be in order for both premises to be true, but the conclusion false, right? So that's this instance right here, and S was true and W was false. So whenever S is true and W is false, the premises are going to be true, but the conclusion's false. So this would be considered the counterexample. And it's showing that the argument's not valid. Let's look at the next example. We have two premises to this argument. P implies Q, and then Q or not R. And then my conclusion is not R. So let's set up a truth table. So we have P, Q, and R. My first premise is P implies Q. My second premise is Q or not R. And then my conclusion is not R. So let's start setting up our table. So let's make the truth value combinations for P, Q, and R. Okay. Now let's look at our premises. First one is P implies Q. So I have a conditional statement and I'm looking at the first two columns, right? P implies Q. So the first two, right, are going to be true to true. So those are both going to be true. Then we have two true to falses. That's the case where the conditional is false. Then the rest are either false to true or false to false. And those are all going to be true. So now my second premise is Q or not R. And if you want, it might be easier to fill in the not R column since we need it anyway, right? So let's just negate R. So we're going to have false, true, false, true, false, true, false, true. So now let's look at Q or not R. So the only way an or statement is going to be false is if they're both false. Everything else is going to be true. So we're looking at the second column and the last column. So we're going to have true or false, which is true. Then we have true or true, which is true. Then we have false or false, which is false. Then we have false or true, which is true. True or false, which is true. True or true, which is true. Again, we have false or false, which is false. Then false or true, which is true. And we already filled out the conclusion column, right? The not R, because we needed it anyway. So let's see when our premises are both true. So there's a bunch of cases where both premises are true. So I highlighted them all or circled them all in red. Now let's look at the conclusion. The first one's false, so right away it makes this argument invalid. But since I want to list the counterexample, let's go through and see if there's any other cases where the conclusion's false. So like here, the conclusion's true. Here we have a false conclusion. And then here my conclusion is true. And then here we also have a true conclusion when both premises are true. So in this case, we're going to have two counterexamples. So these instances, when both premises are true and the conclusion is false, happens for these truth values for P, Q, and R, and these truth values for P, Q, and R. So P, Q, and R would all have to be true to lead to a false conclusion, but true premises. And then P would have to be false, Q and R would have to be true. So that would be my two counter examples. And that shows that the argument is invalid. So let's do one more example. We have the last one. And I'll do that right here. So now that we've completed this example, I'm going to erase the chart that we just did. But if you're not finished copying down yet, or you still want to look at this for another minute, pause and do so. But I'm going to erase it and then move on to the next one. All right, so let's look at this third example, and this will be the final example for section 2.1. We have two premises, R implies W or not S, and not W or not S, and then we have the conclusion R. So let's set up our truth table. So we have R, W, and S. And my first premise is R implies W or not S. So before we actually list the premise, it might just be easier to do this in two steps. So let's just make a column for W or not S. And then now let's do R implies W or not S. And then we have the other premise, not W or not S. And then my conclusion is R, and we're starting off the truth table with R. So now let's get started with the truth values. So let's list all the combos for R, W, and S. All right, so let's look at W or not S. We could have included a column for not S, but at this point, I feel like we've done enough of these that you could kind of do that in your head, right? So for example, W or not S, this first one, just negate S as we're doing this, right? So we're going to have true, false, right? True or false, which is true. The next one is going to be true or true, which is true. Then we have false or false, which is false. Then we have false or true, which is true. True or false, which is true. True or true, which is true. False or false, which is false. And then false or true, which is true. So I was kind of just negating S in my head as I was going along. So now let's look at the first premise. R implies W or not S. So R is my first column, so we're going to look at R implies and then whatever we have in the fourth column. So true to true is true, true to true is true, true to false is false, true to true is true, false to true is true, false to true is true, false to false is true, and false to true is true. And now let's look at that second premise, not W or not S. So I'm just going to negate this fourth column, right? Because that's W or not S, but we want not W or not S. So I'm just going to negate this column. So we have false, false, true, false, 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 true, false. So all I did was negate all the values in that fourth column. And my conclusion is R, which we already have in that first column. So now we're ready to look at all the instances where the premises are true. So my premises are in the last two columns. So the only instance where both premises are true is the one that I circled in red. So now let's look at the conclusion. The conclusion R is false in this case. Therefore, the argument is invalid, and my counterexample, RWS. So when this case is true, when both your premises are true and the conclusion's false, R is false, W is false, S is true, right? If we look at the truth values. So that's going to be my counterexample. When R and W are both false and S is true, the premises are going to be true, but the conclusion is false, therefore making the argument invalid. And that would be our counterexample. So that wraps up section 2.1. In the next lecture, we'll cover 2.2.